Yeah, so we will start in 2 3 more minutes. I will wait. Then we will start.
Okay, which week we are discussing today?
Uh, Sorry, I cannot hear you.
Which week are we going to discuss today?
We are discussing week 8 today. Uh, so
Okay.
so I will give a quick recap. Let me see how many more join. So am I audible clearly?
Yes, yes, you are audible.
Okay. So let's wait till 6 2 at least. Let's see how many more join.
Yeah.
Okay, so let's start. So hello everyone. My name is Rijoy Mukherjee, and this is the live session for NPTEL course on programming in C++. So I am a research scholar at the Department of Computer Science and Engineering, IIT Kharagpur. So we'll be discussing today week 8's coursework, like what was done in week 8. So we'll be solving some questions related to week 8, as well as I will give a quick recap of what was told taught in week 8. So we will start now. Let's just start. So in week 8, let me just discuss it a little bit. So in week 8, we are like previously in previous like weeks we are taught like virtual functions, polymorphism, encapsulation, inheritance, those kind of concepts. So this is a completely different topic. So first that was taught for week 8 was exception, exception handling. So exception handling is a like every programming language provides some kind of exception handling things. So what do you mean by an exception? So in programming construct, exception is basically anything that creates an error in the program. So there are some errors that occur during runtime. So as you know, anything anything divisible by zero. So you know that anything when divisible by zero, it will raise a error, runtime error. So an exception. Similarly, suppose you have an array of size 10, but you are trying to add elements more to it. Suppose you are trying to add more elements like at 11th position, like that. So it will give a error, or you are trying to access a memory outside of the size 10. So that will also give an error. So these kind of things are one things that are not logically correct, but those are runtime that those will give error. So C++ gives us certain programming constructs called exception, which help us solving this issue. So one, so how we do that? So we have a try and we have a catch. So whatever code you write under try, you see that is kind of a sandbox. So inside that sandbox, whatever you write, if it generates an error, it will come here and you can print that error. Suppose it is a exception of type E, so you can print that. So in the week we discussed there are some like common C++ error. So that has some inbuilt exception raised. Now C++ does not just give you the option that okay, only these exceptions you can only handle, only this you can use for try and catch block. It also gives you the option to define your own exception handling mechanism. So you can just give your own side, like suppose you have a code to check whether salary is negative given. Suppose you have an like you I know like you fill different Google Forms or something like yeah, so Google Form is one of the very good example. So suppose you have been given a Google Form and you have been told enter your salary, right? So your salary should be between like something between 0 to like any number, like let's say 1000, but you are trying to give an input of -50, right? So one can try to give such things. So when you try to give a -50 to that Google Form, so it should raise an error like pop-up, right? Like error, you have given a wrong input, please try again. So these kind of things can be written in C++ code using exception. So it will just throw an exception and that will code will be like that. So this, it will write a code here. So if salary is less than 0, throw is the keyword to create that exception. Throw salary less than exception, and that will be caught here, and here you can write the code for that pop-up and it can be shown on the like web page or something. So this is how this is the main crux of how exception works in real life codes or something. So one more thing that exception gave us was like there were some also discussed some C-based exception like assert or those kind of things, but I feel those are not much necessary because this is a C++ codes, and this would be enough for your like understanding how like exception works in C++. Okay, so any doubt regarding this? Okay, so let's look at the other thing that was discussed. The other part that was discussed this week was templates. Now, what are templates? So, one thing you have gone through previously in this coursework was one thing called function overloading. What you used to do it for function overloading? Suppose you have a code like find max, and you have given two integer type parameters. It takes two integer type parameters. So like you want like a similar function for, let's say let's say for double. So uh, like using function overloading, you can just write it as find max and sorry, double comma double. So using function overloading, you can write two different max for int and double, but the underlying logic for checking a min or max, are same. So it doesn't make any sense to write same code every time for finding a min or max. So C++ gave us a very cool concept of template, so that you don't have to rewrite the code. Instead, when you write such a code of min or max, you can write for a template type name t find max tt1 tt2, and then you write your code here, the logic for the code. Now another problem arises when you are doing this template programming. Now suppose the problem is that when you are doing it for something like for like a particular class, like you don't want to use it for min or max. Suppose int double or float. So let's say for string you want to do it. Now what is the problem here? So your simple greater than and less than won't work here for a string. So string uses something called string compare. So for that you can write a simply specialization. So you remember we have this thing called specialization and generalization when you are doing the like the week for class inheritance. So base class was called generalization and the derived class are called specializations. So similarly things you can write here. So this you can consider as a generalization, and for a something called string you can write template string find max string 1 string 2 and the rest of the code here. So this is kind of a specialization for templates. So this was the thing that was done. So this was function template. So similarly you had the concept of class template to along with this. So class template, similarly like to function template, you can write the whole class using a variable t, and all the member functions and the member data members can be just assigned like that. So that was another thing that was taught. Other than that, the other problem that was discussed was the thing called functors or function pointers. A very simple usage of function pointer or functors you have used, but you haven't like thought about it while you are using it, was when you are using the standard template language STL library of C++ for quick sort, or let's say sorting algorithms. So there, not only you need to mention begin, end, you also need to give a comparator function. So at that time you write the name of the just the function what you with using which you need to you are trying to compare the list, the elements of the list. So that is a concept of functor. So you has to pass the function name, or also you can pass function pointer. So another thing, any class with a member function operator this any class which has this a data member of this signature is also a functor, basically defined as a functor. So this was the concept of functor. So templates are used for generalization as well as specialization, so that you don't have to write codes every time. Functors are generally used in this kind of as a comparator kind of sort of things when you need to compare two or more variables. And the third was the exception which I discussed previously. So now let's jump to the model questions which I have prepared for this week. So this is the first question. So if you have any problem viewing this, so let me share it with you. Uh, so you can find it in this link. So this is the first question. So you have been given to like uh, mm, this is a question on exception handling. So you have been given uh, like function. This is the main, and this is the complete main statement. These two, this. So it has been told in the statement, if the statement 1 is replaced by test IT 3.14 and test IT 0, so what will be the output in each case? So let's give it a try with test IT 3.14. So when we pass 3.14, so when we pass 3.14 here, what happens? So this is a double, 3.14 is double. So when we pass it here, so basically it will be implicitly converted to 3 because it is an int it is receiving. So if 3, throw I, else throw 0. So 3 is basically a non-zero number, so this one will be called, so throw, so this will throw basically 3. Now when there is cascading of cache, what happens when we have a cascading of cache? So when there is a cascading of cache after a try statement, it does a polling instead of you will think that okay, it will search synchronously, like at a time it will check all of them. So there is this concept of polling. So what happens in polling? In polling, it checks each of the catch statement one by one. First it checks this catch statement, then this catch statement, then this catch statement, right? So you see, when it throws 3, it checks this catch statement first. It says, okay, this is an int type, so it will come here and print int. So the output when test is 3.14, it will be int. Okay. Next what will happen when we pass test it 0? So when we pass test it 0 here, so here comes 0, so this condition will fail. So if 0, that means it will come to this one, so it will throw a string. See, it will throw a string. So again it will start the polling. So the polling will start here. Is it a type of int type? No, it is a string type. It is a float type? No, it is a string type. It is a double type? No, it is a string type. Then it will come here. Is it a const char stars type? Yes, it is a string type. So it will print string. So the output will be a int and string. Clear this one? So here I will say a very important thing you need to understand, that how exception are handled. Once from the try statement, if it generates an exception, it does a pooling of the catch statements. It doesn't like, okay, this is a float type I have got, so I will directly go to the float type. No, it will first check the int type, then it will go downwards. So that is the most important concept that this exercise first let us understand. So this one is clear, right? If you have any doubts, you can ask regarding exception handling first. Okay, so let's go to the next one. Okay, so here is another try catch block kind of things are given. So we have to find out what is the what will be the output in this case. So let's analyze the program first and what is happening. This is a very interesting problem. So you have a class internal error. So you have a class internal error and it has a virtual function. Virtual function throw, which returns internal exception. The thing it returns is internal exception. Then you have a class db error and it has its own virtual function throw, and it returns a db exception as its error message. Next you have an SQL error and it has similarly a virtual function and a throw, and it returns a SQL exception. Now here in this try block we are throwing an SQL error. So what will be the output in this case? What will be the output, anyone? These are very like, if you have followed the previous one, so this will be easy for you. So when we are throwing an SQL error, so basically this means creating a SQL error object, right? So this throw will basically print this one, right? SQL exception. But which of the catch block will it use? So the answer will be SQL exception, but which of the catch block it will use? That is a like a good point of discussion. Like which of the catch block will it use for this? Because you see, it will be polling, right? It will be a polling. So which of the catch box it is use? Will it use this, like 1, 2, 3, or 4? So which of the catch block it will use? Anyone if can respond? Uh, no. Why default? Why default? See, it is throwing an SQL error. So let me explain. So the answer lies. No, it is not about string, right? It is not returning a string. If you see, it is returning a const char, and like it is of throw type. So uh, it will return. It will basically calling a object of this type. So this creates an object of SQL error. So uh, so so when polling happens, it will first look into here. It is an object of internal error type? Is it a then it will poll to this, and then it will poll to this. So like your thinking will be, okay, this one will be printed because it is creating an SQL error object. But the problem lies here. The problem becomes like a little bit complex here, is that this also can hold. So this is a uh, uh, so this is, what is this internal error? This is the base class. So this is the base class. Base class can hold derived class object. What is that? Upcasting. So when this error happens, so it comes first to here, and internal error can handle it. So this is the one which prints SQL exception, and the reason is it can. So this is a virtual function. So this has been a virtual function. So by upcasting rules, which we have discussed previously, this can call this object, and so it will throw an SQL exception. Clear. So basically the error that is being generated, it will come from the internal error of the option, not from the SQL error type. So that is the main confusing part here, that yes, it will print SQL exception, but the problem is, since it happens in a polling way, so the internal error only print it. Okay. Any doubt you can ask regarding this? Okay, so let's go to the next one. So you have another such like exception handling thing. So here you have a namespace server exception. Here you have a class internal error. You have a class DB error which does a public inheritance of internal error, and you have an SQL error which does a public inheritance of DB error. So this is a proc function. It uh, it throws a SQL error, and this is the catch block. So basically, when whatever it throws here, it comes here, and it in turn throws a DB error. Okay. So ultimately, in the main block, when they call this proc function, and then they have a particular number of catch blocks. Okay. So the question is, what will be the error? What will be the output in this case? So what will be the output in this case? So like we discussed, so whatever an important point here, this can be considered as a nested try catch block. Okay, so whatever uh, try and catch block inside this block, it gets handled here. So whatever exception that is raised here, it gets handled by this catch. So no further like from this outside this block, no further like exception are generated due to this try block. So now this catch block throws a DB error. So okay, so from this try block, DB error is generated, right? Now which of this catch statement will be called? Which of this catch statement will be called? Anyone can reply. Yes, correct, internal error. Because what happens is pooling, just I said before. And so it will be polling again. So you remember this is a DB error generated, DB error object, and DB error generated. Now you come here. First we come here. Is internal error is basically a base class. You see internal error base class for DB error. For DB error it is the base class, and due to upcasting it can hold the base class object. So it comes here and it gives the internal error as output, and it doesn't check here because this catch block is able to like handle the exception. So the output will be internal error. So the concepts which were used for the last two problems, one is upcasting and another is polling. So exception handling happens in polling, and another is basically upcasting. Due to upcasting, base class can hold derived class objects. So these are the two main themes of these problems. Next, let's go to the. So any doubt regarding this you can ask. So I feel you will not have any more doubts, because the thing I've said are quite similar. Like are basically polling and upcasting. Okay, so let's go to the next one. So here you have another try catch block. So here this is the main function, and this is something called throw it function. Inside the throw it function, it throws a divide by 0 error. So this is basically a string, you can say. Next, what we have here is a catch block. The catch block uh, receives a int type, expects a int type to it, and it also creates a throw. Now you call this try block, and you have this kind of catch blocks. So what will be the output or error in this following code? What will be the output or error in this following codes? You see, uh, a simple thing that you need to understand in this case, exception occurs at runtime. Right, so exception occurs at runtime. So even if this throws divide by 0 as output as an exception, even if it doesn't catches or here, first you need to pass the compile state. After compilation, output file is created. So this program will fail the compile state, and the only reason is we have given this default block as top priority. So this is wrong. So your default cannot be your first catch block. And why? Why default cannot be your first catch block? Because if you give default your first catch block, and since exception handling happens via polling, so what will happen? So if you give the default as the first block, so every exception will pass through it. So every exception will say, okay, this is the default block, the first block, I will pass through it only, because the polling satisfies that it is an exception. It works if none of them are work? No, so it works. So by default, typically this catch block should be at the last, because you see it's a polling mechanism, right? So in the polling mechanism, what happens? Whatever is the first catch block, it will try to go through that catch block. But so in this case, if it was so if in this question, in this program block, if the catch block was the last block, then the output would have been default, right? Because that the throw by 0 is a string. Now the problem here is that the default block is the first block, and you see that is the most powerful thing. Default is the most powerful thing, so it cannot be allowed at the beginning. So that's why C++ designers have made sure that default block cannot be the first choice, and as a result this will generate a compiler error. Compiler error will be generated at line 1, that handler must be the this dot 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 handler must be the last handler for its try block. So lesson from this is your default block should always be the last block. So any doubt regarding this? So okay, let's go to the next one. So up till now we had questions uh, on exception handling. Now this is a question on this is a question on like on your template. So the question is you have this template class T. The class name is modifier. It can take mm, T type. It has a T type data member. It has a constructor. It similarly has a subtract function which subtract T from this val minus 6. So now what will be the things that has to be passed, what will be the um, like uh, like fill in the blanks in line 1 and line 2 such that the output becomes 22.4 and program. So here you have the main function. Sorry, it is little bit haphazard. So this is the question, this is your class T, this is your line 1 and 2, and this is the main function. So in the main function you have an object of modifier d is equal to 26.4, and you have a const_cat type modifier of modifier, and it is creating an object of like s, and the initial value is programming. So and this is d dot subtract, and this is d dot subtract. So you see this is a double type variable. Now if you replace t with double, what happens? So this one will be fine. So double val equals to 0, default value, and 26.4 44 will be given here, and when this subtract minus 4 is given, this will work fine because explicit conversion will happen. Double and int subtraction is okay, and this will return the value correctly as 22.4. Now if you are trying to do the same for string, will this code work for string const_cat star? I will say first thing is no, because first this kind of copy will not work, and second this kind of subtraction won't be allowed, because one will be of const_cat type and another will be of int type. So this kind of subtraction isn't allowed. So what it will be here in this case? So we need to do a specialization for const char star, right? We need to do a specialization of const char star. So it will definitely be a template and class modifier of type const char star. Again, a question is very important. What you have asked is correct. Is it really option D? You see, if you make it a const char star, what will happen? So first of all, this will not be correct. So when you are trying to do this string copy, it will not be allowed. So you need to make it char star. Now a very important question that will arise, sir, it is of const char star and you are trying to make it char star. So this will work. The reason is const char star in this case will basically be a char star of type const. So then it will not break the internal modifications. So this kind of stdr and other modification of the char star will be allowed, right? So it will be of type template t class char star. Option A. Okay, so any doubt regarding this? So this is basically specialization of the template. So generalization, template is generalization, and for one type, that is for char star, we are doing a specialization. Okay, so let's come to the next one. So you have, so this is another question on template. So you have like a code here, main function, and you have a template of type t. First element is t and the second element is of type intn. So now so this intn means, so the second one will accept a value. So it doesn't accept a type, it accepts a value. This is very important. So this is a type and this is a value. Okay, so it is a multiprint. The name of the class is multiprint. It accepts a t type val. Then it has its own output variable, its own multiprint. It has its own multiprint constructor. Now this is the main function. So we are saying int n equals to 3 multiprint. We are creating a multiprint class like object, multiprint object of type string and n, and d dot output we are calling. So what will be the output and error in this uh, code? So what will be the output or error in this code? Yeah, so this will generate an error. So the problem lies here and here. So if you observe, we are passing int n equals to 3 here. So this will generate an error because it expects that value will be there, but it expects it to be a integer type. Like, let me explain more carefully. A constant type. Now why constant? Because this class of type string, this this is basically a template, right? So, and this is basically a class. So this template to class conversion happens at compile time. So this template to class conversion happens at compile time. So this is very important. At compile time, it cannot have a such kind of non-constant value. See, you can just somebody can just rewrite like change the value at like n. So it always expects that it will should be a constant. So this will generate an error at line 2, and the correct way of doing it will be multi print string 3. So you need to write it here 3. That will generate the correct one, not this int n like int of n of int type. So that will generate a problem because at compile time it doesn't have the value of n with it also. So that is a big problem. It should have the value of n with it. At compile time it is not available. It is available to it at runtime. So clear this one. So why this will create an error? So the main task is this template to class conversion happens at compile time, and the value of n is available at runtime. So that is the problem. That this is the problem that we need to address here. Okay, so let's go to the next one. So you have this template and you have this template function. So you have this template and template function. So it expects a type t, and you have these options here. You need to check which of them will generate an error. So which of the following will generate an error, compiler error, for when we create a like when we make a print function call like this? Which of the following? So we'll have a look at all of the options one by one. So first you have print this. So for the compiler, what it sees when we sees this? So it sees 10 type as int and this type as char, and it will generate an error in this case. Now for this, it will find it to be a print of type int and int. You see both are of type int. So this will not generate an error. Now let's come to this one. It will check that it is of type double because of this 0.34, and it is of type int. Okay, so this will also generate an error. Now let's come to this one. It will find it to be of type so this is a explicit conversion. So it will think this is of type int and this 30 of type int. So this will not generate an error. So this will not generate an error. So the only one that will generate an error will A and C. So the crux of the matter here is always use explicit conversion while dealing with templates. So this is a main thing you need to remember for this case, that when we are doing this kind of conversions, it's always better to use explicit conversion when you are using template. Any doubt regarding this? Okay, so let's look at the next question. So you have these. So this is related to the thing which we discussed previously, that functors, or let's say function pointers. So you have this following class definition in C++. So you need to identify the appropriate function pointer declaration, that can point to the function sum belonging to the class computation as fm equals to ampersand of computation colon sum. So uh, so so what are functors or function pointer are described in a briefly way. So function pointers should have the signature of the type it wants to hold. So in this case, it is of type int a and int b. This one's function pointer it wants to hold. So in this case, the function pointer should have this signature, right? The function pointer should have this signature. Next one. Next, it is the it needs to have the signature of the its name as a part of its signature. So the name is fpm, so it should be fpm asterisk. So this is by definition, this should be the function pointer definition that can hold this sum. Now here is another issue. This sum is basically a member function of computation class. So you need to keep this one in mind. So you need to write computation colon colon. Now the last point is the return type, which as in this case is int, it should be int. So the correct answer is D. So you see, the step by step you need to like whenever you have been given as such a function, you need to think step by step in a backward way how you can create the function pointer. So first you need to put the signature and the function pointer name, and then you need to look, is it inside a class or not inside a class. If it inside a class, then you need to give the scope resolution of the class, and also you need to then give the return type for the function pointer, which is same to that of the initial functions. So the correct answer in this case is int computation colon colon star fpm within brackets int int. Any doubt regarding this of how to declare functors or function pointers? Okay, so let's go for the next question. So you have this is a very interesting question for understanding how functors happen in, like how to use functors in C++. So the question is, what should be the appropriate line, fill in the blanks at line 1, so that the output here becomes d equals to 11 and r equals to 2. So initially what happening here, we are passing, we have two variables, a equals to 35 and b equals to 3. Now we are defining a uh, a object of for this division class, that is we are calling it as div, and the value of r in this case is initialized to 0. So now we are doing int d is equal to div a comma b. So this is basically, this will happen only when we have a thing called operator inside this division structure. So since it is returning an integer type, it has to be of type int, and since it is taking two variables of input, it should be of type int d1 and int d2, right? So to define, as I discussed early in the like in this session, that to declare functors, a class or a struct should have operator bracket as its member function. So for this case, for doing this kind of operator overloading, like operator functor, creating this kind of functor, you need to have this signature, this data member int operator brackets int d, int d1, int d2. So that will be the answer for this one. So when you are giving 2 and 11 as input, the sorry, you are giving 3 and 5 as the input, it is coming here. So d will be 35 divided by 3, that is 11, and r, the remainder, r equals to 35 mod 3, that will be 3, sorry, 35 mod 3, that will be 2. So the correct answer is option B. Yeah, so any doubt regarding this? Question 7, okay. But in question 7, question 6, yeah, question 6. Should I explain it again? So if we have passed multiprint string 3 hello, it would have printed hello 3 times. multiple hello, okay, your output. uh, yes, 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 so that would have printed it three times. See, because so these are very small nuances you need to remember while writing a C code. I will come to a very interesting question at the end. Okay, so you see this creation of this class. So this is a template. What you are writing here is a template. This multiprint t name. So this is a template, and you are when you are writing this multiprint string s, at that point the class is being created. So when this happens in compile time, right? So this is not present pre-compilation. This happens only in compile time. The compiler creates the class. So it needs to know the value of n. And but you can see the value of n will only be known to the compiler, like only be known at the runtime. So that is the issue that happens here. So I will come to a very good question that will create or solve more of your doubts. Uh, okay, so let's go to that question first. Okay, I will come to these things later. Yeah, okay. So this is a question that has that is very nice. So what will be the output in this case? So you have been given this uh, line of codes. So what will be the output in this case? So what will be the output in this case? Any answer will be fine. So let me describe it in a better way. Let's start. So you have a construct. It is of template. It is have a template int n, and it has a static const int val equals to 2 into construct n minus 1 colon colon val. Okay. Now it creates. So this is a template. So okay, it doesn't have a this that typically thing that happens, that type name t, but this code is correct. Okay. Now it is having a an exception for func 0. So in that case it is telling that this val value is 1. Okay. Now we are trying to create like we trying to create a like call this func val for output. Now remember I said that compiler converts a template to class, or let's say function, at compile time. So when it starts compiling, it says that okay, this is a fixed value, so this will not give any error. Okay, so now this will call this. Now it come here. it checks that the value of n minus 1 here will be 9. Okay, so val will be 2 into this. So now it will create a func struct 9. Now what happens, that will again the compiler will again create this, right? So even it will come here, it will again be 2 up till for 0 the end condition is 1. So for this is for 10, this is for 9, and this is for 0. So this will be basically 2 into 2 to the power of 10, that will be 1024. So the value that will be printed here will be 1024, right? Now you see here computation is happening, and the computation is happening in compile time, right? This breaks a important thing, that compiler doesn't do the computation, but for this case it needs to do the computation. At the computation is happening at compile time. So this is called a particular, this exception, this particular thing is called template meta program. So this is called template meta program. So in this shows that although the compiler doesn't have to, doesn't do any calculation at compile time, but in this case while dealing with structures it need to do, because you see they have by force they have made this func struct as 10. It is a constant, and so it has to continue that process. Okay, this is a constant, so I have to and we are expanding the template only, so we need to do it. So this is the major exception. So the moral of the story is compiler that converts a template to a class at compile time, and in that case if it had to do some computation like this, it has to do it. It cannot just leave it like that. Okay, so this is the main backstory behind this. Any doubt regarding this, you can ask. So do you have to tell the compiler to do the calculation for a template during compile time? No. Compiler, remember number one, compiler doesn't do any calculation typically during compile time. But in this case, you see, the main reason compiler doesn't do any computation. So okay, I'm not saying that it doesn't do any computation, but suppose, let's say there is something you have given us. Suppose you have written a statement int n equals to 7 plus 1. You have declared it as this, int n equals to 7 plus 1. In that case, compiler will rewrite it as int n equals to 8. Because you see that 7 plus 1 means 8, and it doesn't need a particular particular hardware to do that. So you see, every program that we are writing, it has to run somewhere, right? It basically uses the hardware to run. So it checks that this 7 plus 1 is a constant addition. It doesn't have to rely on let's say hardware to do it. It can do it upon itself. So in those cases, calculation it does. In this case, you can consider it as same. So 10 it is passing, that is fixed. So when it comes to func struct n minus 1 inside the func struct, it basically see that okay, this is, I know the value of n, I have the value of n, that is 9, and 1 is also a constant, so 9 minus 1 is 8. So okay, in that case the calculation is happens. So compiler is smart enough, you do not have to do anything. So these kind of cases compiler can handle. But the example which we saw previously, that question number 6, the problem with question number 6 is here the value compiler doesn't know that n, because in that case n has to be constant. You see 10 is constant but n is not constant. That is what I'm saying, n is constant, like this, what is that, here the n is not constant, but what we are passing there is 10. 10 is constant, n is not constant. So if like I have said it again, like here, so question 12, yeah, so sorry, it is not 12, it is something like 13 or 14. Here the value of, see, once it creates this template, so once it does this, so it basically creates this structure, right? So this structure it creates and it substitutes the value of n here, so that is 10, so it becomes 9. 10 minus 1 is 9. So in that case the value is available. So in that case the value is available to it. But here the in question number 6, the n is not available to it. The like the 3 is not available to it, n is available to it. But in this case 10 is available to it. No, it would not work. So if you write this code will run, but that question 6 will not work. It's that the same, that n is not available to him, but like for when you writing n, so that means it is 3. The value of 3 is not available to him, n is available to him, and it cannot use n. But in this case 10 is available to him, and it is creating the object, it is creating the structure by substituting all the values. So when you are substituting this func struct n minus 1, so that n minus 1, it knows the values of 10 already, so that's why it is working. So this is the main difference. Okay, yeah. So I will come to another like useful question, this. So what will be the output in this case? This is also a very good question, in a sense that what happens of static thing? What is static, and when what is a like a static object, or in respect to a class. So what will be the output in this case? You see what we have here. You have a template class T. It has a private member function val. It has a static member count, and it has a like constructor which increases the value of count. And here we are defining the count. So now what will be the output here? So what we are doing, we are creating a we are creating a B, and we are creating a C. A is of type test int, B is of type test int, and C is of type test double. So we are printing test int count, and test double count. So what will be the output of this one? Uh, here no 3 comma 3 is not correct. So the crux of this problem is again template and class. So this template to class conversion is done by compiler. So when you are writing test int, this is a class, and we are writing test double. So let me call it as class 1. This is another class, class 2. So these are basically two different classes, even though they are made from the same template, right? So this will create one class of class int, or one object of class int type. This will create another object of class int type, and this will create a different object of class test double. So you see, we are creating two objects of test int and one object of test double, which means this count value here of test int will be 2 and test double count will be 1, because static variables are shared between the classes. So whenever these two constructors are created of the same class, so this value becomes 2, and for test double only one class is created, so value become so one object is created, so it value remains 1. So the main the topic of discussion for this problem is that uh, the class that is created from the same template are different for different values of type. So for int type a different class, and for double type a different class. Any doubt regarding this? These are very basic things that will help you understand like how template works, and what is the difference between a template and a class, or a template of or a function. Okay, so I will come to another quick topic which was not discussed. I saw in the like in your lectures. So templates and default arguments. Yeah. So you see, you have been introduced to the term default arguments, default parameters when we are doing functions, member functions, function overloading, those kind of things. Now you see, for templates also you can give default arguments. So let's look at this problem. So look at this, let's say piece of code. So you have a template class T, class U, and the default value we have given as char. So we are it has two member functions of type T and U. Then we are writing a main, a char. So we are creating two classes. So of class A char A, and int B. So basically, so the question is find the size of what will be the output of the size of A and B. So you see, for when we write only A char, so it becomes, when, because a default argument is given here, so it becomes basically a class of char comma char, and this one is basically A of int comma int type. So if by standard practice, that is int of 4 byte and char of 1, so the output in this case will be 2 and 8. Yeah. So this like this is a typically like what you have, how you have discussed default arguments in case of a function. So same way default arguments exist for templates also. This is important. Now like you have found out like in functions, that when you like this is not possible. So if you declare this one as default argument, so you have to define all of them should be default. So this will throw an error. So that is another major like thing that you need to remember, that templates and default arguments can happen. But like when you are doing program constructs, like in that case is like these things will be very helpful. So what will be the default argument and those kind of things. So this is a good topic. Uh, so let's come back to some of the questions I skipped previously. So let's come to this one. This was one of the like your assignment questions. So you have been given this piece of code. You need to fill in the blanks, line 1, 2, 3 and 4. So if you are given an input of 10, 20, 30, 40, 50, the outputs would be 30. Okay. So so you need to fill in the blanks for this. So like when gives you such a question of fill in the blanks and this and output, this becomes a notoriously difficult to understand what it should be and what it should not be. So let's start this and how to approach this. So let's look at first the main part of the code. What it is doing, it has a size object, it has IA size, and then it has taking inputs for IA, then it is assigning a variable as average, and then it is passing both the values IA and AVG, and then it is printing AVG. So, so first of all, look at this one. You see size. Now you know if we write int size equals to 5, this will generate a error because array size should be constant. So in this case it has to be const int, right? You can think it as the similar way when we are like a similar thing that like when we are discussing that template one, that why int n, like n cannot be given as like input. So this is one of the same category kind of thing. You can say that array has to be have a constant memory address, like memory length that has to be given. So constant int size. Next, this is basically saying that we are calculating an average. Now let's look at like this has to be a template because we were defining this and this and this. So first two are, so two type names because int and double are type names, and one integer. So it should be, the signature of the template should be template type name, let's say t1, type name t2, comma int n, right? Now we need to define this function. So this will be void average it will take t1 arr star slash, you see we are sending an avj as a, we are sending avj, so since this output has to be updated here, so we need to send it as as a like reference. So you need to send it as a reference. So this will be T2 average reference. So now here you need to define this T1 total equals to 0. So because this is the only variable that has not been initialized and it is of type T1. So because this is int type and we are adding those, so T1 total is equals to 0, and then the rest will follow like that. So we are adding all the elements, storing it in total, and then we are creating a like average for the total. So this is how you need to approach this kind of uh, like uh, fill in the blanks, you can say. So from top to down you need to go. So first we defined the const int type, the size, because it has to be a const int, else it will throw an error. Then we defined that two types, because it are taking two different types of elements. One is of int type and another is of double type, and the third one you see it is of 5, so it has to be a variable, in this case value. Then we are defined the function void average t1 a star, that is the array, and average has to be, you see average value is getting updated, so it has to be passed as a reference. Next we define the total variable, t1 total equals to 0, and then the rest code will follow, where it is basically an addition and then by in a division to create the average. Clear? So let's go to the if you have any doubt you can ask regarding this. Okay, let's come to this one. So you have these lines you need to fill in the blanks, and this is the main function, right? So you are taking so let's see what is the main function doing actually. So you are taking main function, we have an a and a b and two arrays c and d, c of int type, d of double type, and then we are, so this code is basically populating c, and this code is basically populating d. Now we are creating five values template or class from the template, five values of type int and 5, and we are printing them. Similarly we are printing the doubles, creating a one for double, and we are printing them. Now what is happening in this case? The output, if you check the output, so all the inputs are multiplied by 10, right? So let's go over this one by one. So this one will be template for the 5 files, template. So you see it takes a type, only one type of for each type name slash int type, int integer of n. So here they are using the n. So this will be the template signature. Next, what is happening here? Type name will be type. Sorry, it is given here. Type name will be type. Next, what is happening here? So basically, we need to do a new array here. So we have a pointer for the array. So you need to do what? A base slash new type n. So this will create a array, new array, like this will create, this will initialize the base with this pointer that will be created by this new statement. Base initialized by pointer to this new statement, right? Now line 1 and line 2 is done. Now let's come to this one. So basically what happening here is we are writing the print statement here. So you see what here it will be. Here you need to, whenever, so this is an important exercise to understand. So if you have a print function, you have declared the print function inside but you have not defined it, so how to write the definition outside of the class, because class gives us the option to write the definition outside. So how to write the definition? So you need to write it like this. Template slash type name type INTN. So basically you need to copy this definition, this signature here also, and then write like how you write for other uh, functions, 5 vals type comma in, right? So this is similar way to how you define a normal member function of a variable outside the class. Let me write it once again. Void 5 void 5 vals, that is type and in colon print this. So this will give you the this is how you define the variable of member function of a template outside of the template. So like quite similar to that how you use a normal class, except you need to define, you have to give the template's signature again, and as well as how you call that. So this is the two way you need to remember. So one is write the signature again, and two, write the function and type variables. So that's conclude like how to use this, like how to use the function, write a function outside of the template. Okay, so let's go to the next one. So here you have a class called complex, and output, like we have seen this code previously, like how to overload this output symbol or string. You have this main module, like and you have this complex type complex data type, like user defined data type. This is its constructor. These are its get function. These are this data member, and this is the friend function using which we are printing the mm, over printing the variable. Now you see here what we have. Here you have few double variables a, b, c, d, and few int variables, and we are taking input of all of them. So first four are the double variables, and next two are the int variables. Now we are creating two complex numbers from it, that is using a and b. So if the input is 10.4, 4.5, 2.5 and 2.5, so it will become 10.4 plus 4.5i and 2.5 plus 2.5i. Now it is saying add like add complex c1 comma c2, right? Now it also has an add of int type, right? So basically we need to write a template for this one. So the template will be template slash type name t, and it will have the function add, return type will be t, and it will be sorry, so it is already given here, sorry. So it will be simple template type name t, and it will keep. Now you see the problem lies in this. So this one is fine for simple standard variables like int. Now we need to give a specification for this complex type of thing. So what you need to do is we need to give it as template. We need to give a specialization template this complex add complex like complex n1 comma complex n2. So that will do the generalization of this specialization. So that will do the specialization for complex class, right? So that will give the output, that will do this operation and give the output. Okay, so any doubt regarding this? So if you have any doubt regarding any of the problem, you can ask. This one was the last one, so we have discussed all of them. So let me just check all of them one at once. So this one was the exception handling part. So one important thing from the exception handling part, which I feel is very important, is exception handling occurs via polling. So it polls each catch statement, and whichever it finds is suitable, it uses that. Not it is not like not all at a time. It is polled via polling sequentially. Next, we defined and played with around with this template kind of things. Specialization we checked. We also checked why how a value is passed uh, in a template. Then we also checked this type conversion, that explicit type conversion should be used in this case of templates. Then we looked at functors and how functors are defined in C++. Then we looked at this static and learned the important thing is that template to class conversion occurs at compile time. So and also this two int test means basically only one class is created. So once when the first uh, instruction is fetched, it creates a class, and for the second the class is not created, same class is used. This is one another. Then we looked at this template meta program, and we also looked at this templates and default argument case. Okay, do you have any suggestion for a good textbook for understanding? Yeah, I will suggest I when I studied template programming like C++, so I started using that book of E. Balagur Swami of C++. So that book you can check it out. That is a quite a standard book, textbook. Other than that, internet you have lots of resources. Geeks for Geeks is a very good website for those. Textbook I will suggest that E. Balaguru Swami book. That is a very good book to understand C++. And not only C++, like every concept of C++, not only template. Yeah, let me copy it once. Programming with C++ by E. Balaguru Swami. Okay, so thank you. Uh, Please join next week also. Yeah, you can leave if you have no don't have any doubt.